Looking at moderate intensity and moderate duration, now the dominant energy system in this would be the anaerobic glycolytic system, and this uses glycogen, which can be found in the triglyceride stores in the muscle fibers. And the neuromuscular system then recruits FOG, fast oxidative glycolytic muscle fibers, to work with the fast glycolytic muscle fibers. And this produces a waste product of lactic acid. And during exercise, some lactate can be broken down for energy, but there becomes a point where the intensity is high enough where the body can't break down the lactate fast enough, and this causes an increase in blood lactate levels, shown in the graph over here, where the lactate threshold is. That is where the point where the intensity becomes too much for the body, where blood lactate then begins to increase. And this is the point where the body can no longer break down the lactate fast enough. OBLA here is a generalized point at 4 millimoles to show the level of fitness for the performer. And in lactic acid, this is then broken down where there isn't a presence of oxygen into lactate and hydrogen ions. And these hydrogen ions cause a decrease in pH of the muscles, and then when they're built up to a high enough volume, this will cause the enzymes responsible in glycolysis to be inhibited, and therefore physically cause a reduction of intensity for the performer as a way of protecting the body from damage. This is usually seen in a 400 meter sprint, as the body is trying to work at a high possible intensity for the performer, so that they can get the quickest time. And as they get probably into the last 100 meters down the straight, these hydrogen ions would have built up so much that the muscles and the enzymes that cause the muscles to contract would be so acidic that they physically wouldn't want to work, or would physically cause the performer to slow down, which is why they can't maintain their maximum intensity for the full 400 meters. To delay fatigue in moderate intensity, moderate duration, you first have you can first use soda loading, and this is ingesting sodium bicarbonate a few minutes before an event to cause the body to be slightly alkaline. So this means that a greater amount of lactic acid can be built up to increase the pH to such a level of acidity that causes the enzymes to be inhibited, meaning that the performer can work at that high intensity for longer, as it would take longer for the hydrogen ions to build up to a level that would cause the enzymes to be inhibited. There are side effects of this though, if the performer isn't used to training with it, so can cause vomiting or even diarrhea. Looking at this graph, it shows that for two groups of people, one group using bicarbonate soda for soda loading, and another group using a placebo. Beginning with, they can both work for 400 seconds at 100% of their VO2 max. And after the 8-week training course, the bicarbonate group clearly showed a greater improvement compared to the placebo group. So they can maintain their VO2 max for approximately 1,300 seconds, which is even though they both increased, a much bigger increase compared to the placebo group. Another way to delay fatigue is by glucose ingestion, and this is done mainly in high intensity but intervals of high intensity, where an ingestion of a glucose-rich drink, such as many energy drinks, would mean that they would be able to begin the next interval with a high glucose level, as their levels of glucose would be depleted from the previous amount of high intensity work, meaning that they can maintain their high intensity throughout different intervals.